Tonight, you do not need to do anything at all. You do not need to remember any of this. You do not need to take notes. You do not need to stay awake until the end. You are simply here, resting, and that is more than enough. If you would like, you might let your eyes close. You might let your shoulders drop just a little. You might notice the surface beneath you, how it holds you without asking anything in return. And if your mind is still busy, still turning over the events of the day, that is perfectly fine. It will quiet down on its own. There is no rush. Tonight, we are going to talk about something that is happening inside you right now, at this very moment. Whether you are aware of it or not, we are going to talk about your blood, not in the way a textbook might describe it, not with urgency or alarm, but gently, the way you might describe a river to someone who has never seen one, with wonder, and with quiet respect for something that has been flowing long before anyone thought to give it a name. Right now, as you lie here, approximately 5 liters of blood are moving through your body. A warm, quiet river that began flowing the moment your heart first beat, and has not stopped since. It is flowing through 100,000 kilometers of blood vessels, enough to wrap around the earth 2.5 times. And yet, it all fits inside you. Every vessel, every drop, every cell. And the iron in that blood, the iron that gives it its color, the iron that carries oxygen from your lungs to every cell in your body, that iron was not made on Earth. It was forged billions of years ago, in the heart of a dying star. When that star collapsed, it scattered its iron across the universe, and some of that iron, a tiny ancient fragment, found its way into you. You are, quite literally, breathing with stardust. Over the next 2 hours or so, we will follow 100 gentle facts about this river, the river inside you. You may fall asleep before we reach the end, and that is perfectly fine. In fact, that might be the most beautiful way to listen. We will begin with the river itself, what flows through you right now, how it moves, what it carries. Then we will meet the quiet guardians who patrol its banks, the cells that protect you while you sleep. We will trace this river back through 500 million years of life on Earth, through blue-blooded horseshoe crabs and transparent-blooded icefish and ancient oceans that still echo in your veins. And finally, we will rest beside the river as it slows down for the night, just as you are slowing down now. So let us begin. Here is your first fact, and it is a gentle one. The first thing to know about your blood is simply how much of it there is and how quietly it moves. Fact 1. The 5-liter river. An average adult carries approximately 5 liters of blood inside their body at any given moment. That is roughly 1.3 gallons of warm, quiet, liquid, flowing through you right now as you listen to this. 5 liters may not sound like very much. It would fit inside a large water bottle. And yet, this small volume of fluid is responsible for delivering oxygen to every cell in your body, removing waste, carrying hormones and nutrients, and maintaining the delicate temperature that keeps you alive. It does all of this continuously, without pause, without rest, every single moment of every single day. If you were to pour those 5 liters into a glass, it would look like an ordinary red liquid, but inside you, it is a river with its own current, its own rhythm, its own quiet intelligence. It knows where to go. It knows what to carry. It knows how to find the cells that need oxygen and leave behind what they no longer want. Perhaps you might notice the warmth in your hands or your feet right now. That warmth is your blood, flowing. It has been there all day, and it will be there all night. You do not need to direct it. You do not need to think about it. It simply flows. And so we begin with this 5 liters of quiet, flowing life. Fact 2. 25 trillion travelers. Your body contains roughly 25 trillion red blood cells at any given moment. That is 25 followed by 12 zeros, a number so large that it is almost impossible to hold in your mind. To put it in perspective, the Milky Way galaxy contains an estimated 100 billion stars. Your body holds roughly 3,000 times that number in red blood cells alone. You carry more red blood cells than there are stars in 3,000 galaxies. Each one of these cells is incredibly small, about 7 micrometers across, which is roughly 1/10 the width of a human hair. And yet, each one has a purpose. Each one carries oxygen. Each one travels through your blood vessels, delivering what your tissues need and returning to the lungs for more. They are not random. They are not chaotic. They are a vast, coordinated river of travelers, each one knowing its role, each one moving with the current. If you would like, you might imagine them now, 25 trillion tiny travelers, all moving through you at this very moment, all carrying something you need. You do not need to count them. You do not need to understand the number. Just know that they are there, and they are working for you, quietly, as you rest. Fact 3. 270 million cradles. Each red blood cell carries approximately 270 million molecules of hemoglobin. Hemoglobin is the protein that binds to oxygen in your lungs and carries it to the rest of your body. Without it, your blood would have no way to transport the oxygen you breathe. 270 million molecules in a single cell, and there are 25 trillion of those cells in your body. The total number of hemoglobin molecules inside you is a figure so vast that it would take longer than a human lifetime to count them, even if you counted one every second. Each hemoglobin molecule has a small pocket at its center, and in that pocket sits an atom of iron. This iron atom is what actually holds the oxygen, gripping it gently in the lungs and releasing it gently in the tissues. It is one of the most elegant systems in all of biology. You might think of each hemoglobin molecule as a tiny cradle, holding oxygen the way a cupped hand might hold a drop of water carefully, gently, just long enough to carry it where it needs to go. Perhaps you can feel your own breathing right now, slow and steady. With every breath, millions of those cradles are being filled, and with every heartbeat, they are being sent on their way. Fact 4. Iron forged in dying stars. The iron in your hemoglobin was not made on Earth. It was created billions of years ago, inside the core of a massive star, through a process called stellar nucleosynthesis. Stars spend most of their lives fusing hydrogen into helium. As they age, they begin fusing heavier elements, carbon, oxygen, silicon, layer by layer, like the rings of an onion. Iron is the last element a star can create through fusion. Once a star begins producing iron, it has reached the end of its life. When that star finally collapses and explodes in a supernova, the iron is scattered across space, drifting through nebulae, settling into dust clouds. eventually becoming part of the matter that formed our solar system, our planet, and, ultimately, you, the iron sitting inside your hemoglobin right now, carrying your oxygen, coloring your blood. That iron was forged in the heart of a star that no longer exists. You are breathing with the remnants of a supernova. You are, in the most literal sense, made of starlight. Maybe you can let that thought settle softly. There is no need to hold it tightly. Just let it rest somewhere quiet, the knowledge that you carry something ancient and cosmic inside your veins. And it is working for you, right now, as you drift. Fact 5. 100 billion new cells every day. Your bone marrow produces approximately 100 billion new blood cells every single day. That is roughly 1.2 million new cells every second, assembled quietly inside the spongy tissue of your bones, without you ever feeling it happen. This production never stops. It has been running since before you were born, and it will continue for as long as you are alive. Your body replaces its entire supply of red blood cells roughly every 4 months, cycling through generation after generation of cells, each one built to the same precise specifications. The process is called hematopoiesis, a word that means, simply, the making of blood. It happens primarily in the marrow of your larger bones, your pelvis, your sternum, your vertebrae, the long bones of your legs. These are not just structural supports. They are factories, gardens, nurseries, places where the raw materials of life are assembled into the cells that keep you alive. Perhaps it is comforting to know that even now, as you rest, your body is building. It is making new cells, new carriers, new travelers for the river. You do not need to ask it to. It simply does. And the river continues to flow. Fact 6. The 120-day journey. Each red blood cell lives for approximately 120 days. During that time, it travels an estimated 300 kilometers per day through your circulatory system, roughly the distance from New York to Philadelphia, or from London to Paris, every single day. Over the course of its lifetime, a single red blood cell will travel roughly 36,000 kilometers, nearly the circumference of the Earth. It will pass through your heart approximately 75,000 times. It will squeeze through capillaries narrower than itself, flex and fold its membrane to fit, and then spring back to its original shape. And at the end of those 120 days, the cell will be gently removed from circulation by your spleen broken down, its iron recycled, its components returned to the marrow to build something new. It is a life of quiet service, born in the marrow, traveling the river, delivering oxygen to every corner of your body, and then returning to where it began. No fanfare, no recognition, just the steady, faithful work of keeping you alive. You might let your body soften a little more as you consider this, the idea that billions of cells inside you are completing this journey right now, and they have been doing so every day of your life. Fact 7. Tiny pillows. Red blood cells are shaped like biconcave discs, flat and round, with a gentle dimple on each side, like tiny pillows that have been softly pressed in the center. This shape is not accidental. It is one of the most elegant designs in biology. The biconcave form gives the cell a large surface area relative to its volume, which means more oxygen can bind to the hemoglobin inside. It also makes the cell incredibly flexible, able to fold and bend and squeeze through capillaries that are narrower than the cell itself. Imagine pressing a soft pillow through a narrow space. It deforms, passes through, and then gently springs back to its original shape. Red blood cells do this thousands of times a day, navigating the tightest passages in your circulatory system without breaking. There is something restful about this image. Billions of tiny pillows flowing softly through you, bending and yielding and always returning to their gentle shape. Perhaps you can feel the softness in your own body right now. Perhaps you might let your jaw relax, your forehead smooth, your hands uncurl, like a red blood cell finding its way through a narrow capillary. You can soften and still arrive where you need to be. Fact 8. The sacrifice of the nucleus. Mature red blood cells have no nucleus. Unlike almost every other cell in your body, they have expelled their own DNA, sacrificed the very thing that makes a cell, so that they could carry more oxygen for you. When a red blood cell is first formed in the bone marrow, it has a nucleus, just like any other cell. But as it matures, it pushes the nucleus out, along with most of its other internal structures. What remains is essentially a flexible sac filled with hemoglobin, a cell that has given up its own identity to serve a single purpose. This is why red blood cells cannot repair themselves or divide. Once they are released into the bloodstream, they have no way to renew. They simply do their work for 120 days, and then they are done. There is something quietly noble about this, a cell that gives up its own blueprint so that you can breathe. It does not ask to be remembered. It does not ask for anything at all. It simply carries your oxygen until it cannot anymore, and then it returns to the river. Maybe you can let your breathing deepen, just slightly. Each breath is a gift received by cells that gave up everything to carry it. Fact 9. The garden inside your bones. All blood cells begin their lives in the spongy tissue inside your bones, a soft, reddish material called bone marrow. Your skeleton is not just structure. It is a garden where blood is born. Bone marrow is one of the most productive tissues in the human body. It generates red blood cells, white blood cells, and platelets, the three main components of blood, in quantities that are difficult to comprehend. Every second, millions of new cells are being assembled inside your bones, each one carefully built from stem cells that have the ability to become any type of blood cell. The marrow is warm and well supplied with blood of its own. It is a sheltered environment, tucked inside the hard casing of bone, protected from the outside world. In a way, it is the quietest place in your body, a hidden nursery where the river's travelers are born. Perhaps you can feel the weight of your own bones right now, resting against the surface beneath you. Inside those bones, something is growing. Something is being made. Right now. For you. You do not need to direct it. Your body already knows what it needs. And the garden keeps growing. Quietly. In the dark. Fact 10. One cell. Infinite possibilities. A single hematopoietic stem cell in your bone marrow can become any type of blood cell, red, white, or platelet. It is one of the most versatile cells in the human body, guided by chemical signals from the surrounding tissue to become exactly what is needed. If your body needs more oxygen carriers, the stem cell becomes a red blood cell. If there is an immune challenge, it becomes a white blood cell. If there is a need for clotting, it becomes a platelet. The same cell, the same starting point. but with infinite potential outcomes. These stem cells renew themselves throughout your entire life. They are the seed from which the river grows, a perpetual source of new travelers, new guardians, new healers. As long as they are healthy, they can continue producing blood cells for decades. The signals that guide them are like whispers, chemical messages that say, "Become this," or "We need more of that." The stem cell listens and responds, quietly, without hesitation. If you would like, you might imagine your bone marrow right now, a quiet, hidden space inside you where possibilities are being born, where every type of blood cell begins as a single, open question, and the body, gently, provides the answer. Fact 11. Sunrise and sunset in every heartbeat. Oxygenated blood is bright scarlet. Deoxygenated blood is dark crimson. Your body carries both colors at every moment, sunrise and sunset flowing through you in an endless cycle. When blood passes through the lungs and picks up oxygen, the hemoglobin changes shape slightly, and this shift causes it to absorb light differently. The result is the bright red color of arterial blood, the color of oxygen, of breath, of life arriving. When the oxygen has been delivered and the hemoglobin is carrying carbon dioxide back to the lungs, the color deepens to a dark, rich crimson, the color of a task completed, a journey ending, a return. This color change is happening inside you right now. Bright red blood flowing outward through your arteries. Dark crimson blood flowing back through your veins. Two rivers, two colors, two directions, all inside the same body. Perhaps you might notice the quiet rhythm of this cycle, the bright and the dark, the giving and the returning, the sunrise and the sunset. It has been happening with every heartbeat since you were born, and it is happening now, gently, as you rest. Fact 12. The narrow mountain path. The smallest capillaries in your body are only about 5 to 10 micrometers wide. A red blood cell is roughly 7 to 8 micrometers across. This means that in the tightest passages, red blood cells must fold and squeeze through one at a time, like travelers passing through a narrow mountain path. Capillaries are where the real work of blood happens. It is here, in these impossibly thin vessels, that oxygen is released into the tissues and carbon dioxide is picked up for the return trip. The walls of capillaries are just one cell thick, thin enough for gases and nutrients to pass through by diffusion. There are approximately 10 billion capillaries in the human body, forming a vast network that reaches every tissue, every organ, every corner of you. No cell in your body is more than a few cell widths away from a capillary. The river reaches everywhere. Imagine a mountain path so narrow that only one traveler can pass at a time. Each one slows down, squeezes through, delivers what they carry, and moves on. This is happening billions of times a second inside you right now. Maybe you can let your attention soften. The river knows the path. It has been traveling it your entire life. Fact 13. A map that wraps the earth. If you laid all your blood vessels end-to-end arteries, veins, and capillaries, they would stretch approximately 100,000 kilometers. That is enough to circle the earth 2.5 times. 100,000 kilometers of vessels, all inside you, from the aorta, which is roughly the width of a garden hose, to the capillaries, which are thinner than a human hair. a network so vast and so intricate that no human engineer has ever built anything comparable. And yet, this entire network is folded, looped, and layered inside a body that fits on a bed. Every organ is connected. Every tissue is supplied. Every cell receives what it needs, because the network reaches everywhere. The blood completes one full circuit through this system in roughly 60 seconds. In 1 minute, your blood has traveled from your heart to your toes and back again. In 1 hour, it has completed this journey 60 times. By the time you fall asleep tonight, your blood will have circled this network thousands of times. Perhaps you can feel the quiet hum of it now, this vast internal map, working silently. You do not need to trace it. You do not need to follow it. Just know that it is there, connecting everything inside you. Fact 14. 100,000 gentle waves. Your heart pumps blood through your body approximately 100,000 times per day. Each beat is a gentle wave, pushing the river forward through the network of vessels. 100,000 beats. That is roughly 70 beats per minute. 4,200 beats per hour. 100,000 beats per day. Over a lifetime, your heart will beat more than 2.5 billion times, and it will never take a break. Not once. The heart is a muscle about the size of your fist. It sits slightly left of center in your chest, and it contracts and relaxes in a steady rhythm that began before you were born. Each contraction pushes about 70 milliliters of blood into the aorta, a small wave, but enough to keep the entire river moving. You can feel it now, if you would like, the quiet pulse in your chest, in your neck, in your wrists. Each beat is the river being renewed, pushed forward, sent on its way again, 100,000 times today, and 100,000 times tomorrow. Let each beat be a reminder that you are alive, and that something inside you has been working on your behalf since the very beginning. Fact 15. The most precise delivery system. Hemoglobin picks up oxygen in the lungs and releases it in the tissues, but it does not release oxygen randomly. It delivers it precisely where it is needed most, guided by the concentration of oxygen in the surrounding tissue. When hemoglobin arrives in an area with high oxygen levels, like the lungs, it binds oxygen tightly. When it reaches an area with low oxygen levels, like a working muscle or a resting brain, it releases the oxygen gently. This process is described by the oxygen-hemoglobin dissociation curve, a relationship so finely tuned that it responds to changes in pH, temperature, and carbon dioxide levels. This means that when a muscle is working harder and producing more carbon dioxide, the hemoglobin in that area releases even more oxygen to meet the demand. It is a self-adjusting system of extraordinary precision. No human technology has ever matched this level of adaptive, responsive delivery. Your blood adjusts to your body's needs in real time, moment by moment, without any conscious input from you. Perhaps you might notice how effortless your breathing feels right now. You are not directing the oxygen. You are not choosing where it goes. Your blood already knows. Fact 16. The return journey. Blood does not only carry oxygen outward, it also carries carbon dioxide back to the lungs for exhalation, the return journey of the river, carrying away what the body no longer needs. Carbon dioxide is a waste product of cellular metabolism. Every cell in your body produces it as a byproduct of generating energy. If it were allowed to accumulate, it would make the blood dangerously acidic, so the blood carries it away, dissolved in plasma or bound to hemoglobin, and delivers it to the lungs where it can be exhaled with each breath. This return journey is just as vital as the outward one. Without it, the river would become stagnant, filled with waste, unable to deliver what the body needs. But the current flows both ways. Oxygen in, carbon dioxide out. A perfect, continuous exchange. Every breath you take is both a receiving and a releasing. Every exhale carries away something the body has finished with. Perhaps you can feel this exchange happening now, the gentle rhythm of breathing in and breathing out. Receiving and letting go. Your blood is the river between these two shores. Fact 17. The delicate balance. Blood maintains a pH between 7.35 and 7.45, slightly alkaline. This narrow range is one of the most carefully maintained balances in the human body. If blood pH drops below 7.35, a condition called acidosis occurs. If it rises above 7.45, it is called alkalosis. Either extreme can disrupt enzyme function, alter protein structure, and interfere with the chemical reactions that keep you alive. The body has multiple buffering systems to prevent this bicarbonate buffers in the blood, respiratory adjustments in the lungs, and filtration in the kidneys. All of these systems work together, continuously, to keep the pH within that tiny window. It is a balance so precise, so carefully held, that even a small shift would change the way every chemical reaction in your body proceeds. And yet, you do not feel it happening. You do not notice the buffers adjusting, the lungs compensating, the kidneys fine-tuning. It all happens beneath the surface, in the quiet depths of the river. Maybe you can let this be a comfort, the knowledge that your body maintains this exquisite balance without asking for your help. It has been doing so since your very first breath. Fact 18. The golden 55%. Plasma makes up about 55% of your blood volume. It is a golden, straw-colored liquid, mostly water, but carrying an extraordinary cargo of proteins, hormones, nutrients, and dissolved gases. If you were to separate the components of blood in a test tube, the red blood cells would settle to the bottom, forming a dense, dark layer. Above them would be a thin band of white blood cells and platelets, and on top of everything, clear and golden, would be the plasma, the liquid river in which everything else floats. Plasma carries albumin, which maintains blood pressure. It carries immunoglobulins, which fight infection. It carries fibrinogen, which enables clotting. It carries hormones that regulate growth, mood, and metabolism. It carries glucose for energy, amino acids for repair, and electrolytes for nerve function. It is the medium through which the river flows, the golden ocean that carries every message, every nutrient, every defender to where they are needed. Perhaps you might imagine it now, a warm, golden liquid flowing through you, carrying everything your body needs, quiet, transparent, and steady. The river beneath the river. Fact 19. 8 molecular signatures. There are 8 main blood types in the human classification system, determined by the presence or absence of specific antigens on the surface of red blood cells, the A antigen, the B antigen, and the Rh factor. Type A carries the A antigen. Type B carries the B antigen. Type AB carries both. Type O carries neither. Each of these can be positive or negative depending on the Rh factor. This gives us 8 main types: A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. Your blood type is like a molecular signature, a pattern on the surface of your cells that is unique to you and your family. It was determined at the moment of your conception, written into the DNA that you carry in every cell. These signatures do not change over your lifetime. They are a permanent part of you, as constant as the river itself. You might let this thought drift softly, the idea that your blood carries a signature, a quiet code on the surface of every red blood cell that has been there since the beginning of you. Fact 20. The rhesus connection. The Rh factor in blood typing was discovered through research with rhesus monkeys in 1940. It refers to a protein on the surface of red blood cells that is shared between humans and many other primates. About 85% of people have this protein and are classified as Rh positive. About 15% lack it and are classified as Rh negative. The discovery was made by Karl Landsteiner and Alexander Wiener, who noticed that antibodies raised against rhesus monkey blood cells also reacted with some human blood cells. This tiny protein 1 molecule among thousands on the surface of your cells connects your biology to a long evolutionary story. It is a reminder that you share deep biological roots with other primates, and that the chemistry of your blood has been shaped by millions of years of evolution. Perhaps you can feel that connection now, quiet and ancient. A thread that runs not just through your body, but through the history of life itself. Your blood is not just yours. It belongs to a story much older than you. Fact 21. Fast and slow. Blood travels through the aorta at approximately 1.2 meters per second, a brisk, purposeful pace, pushed by the force of the heart's contraction. But by the time it reaches the capillaries, it has slowed to barely a trickle less than 1 millimeter per second. This dramatic change in speed is not a flaw. It is by design. The blood needs to move quickly through the large arteries to reach distant parts of the body. But in the capillaries, where oxygen and nutrients are exchanged with the tissues, it needs to slow down to linger, to allow time for diffusion, to ensure that every cell gets what it needs. It is the same principle as a river, fast in the narrow channels, slow in the wide, shallow banks where the water seeps into the earth. If you would like, you might imagine your own blood slowing down right now, moving quickly through the great vessels near your heart, and then drifting, almost hovering, in the tiny capillaries at your fingertips, fast and slow, urgent and gentle, both at the same time. Perhaps you can feel your own rhythm slowing too. There is no hurry. The river has time. Fact 22. The changing marrow. Children have mostly red bone marrow, the type that actively produces blood cells. But as you grow older, some of that red marrow is gradually replaced by yellow marrow, which stores fat instead. By adulthood, red marrow remains mainly in the flat bones, the pelvis, the sternum, the ribs, the vertebrae, and the ends of the long bones. The rest has been converted to yellow, the body quietly shifting its resources as its needs change. This is not a loss. It is adaptation. Children are growing rapidly, and need a high rate of blood cell production. Adults have settled into a more stable state, and the body reallocates its marrow accordingly. If the body ever needs more red blood cells urgently, some yellow marrow can be converted back to red. It is the body quietly reorganizing itself, without asking permission, without announcing the change. A slow, invisible remodeling that happens over years. Maybe you can appreciate this the way your body has been adjusting and fine-tuning itself your entire life. Quietly, behind the scenes. You do not need to manage it. It manages itself. Fact 23. The gentle hormone. When oxygen levels in your blood drop below a certain point, your kidneys release a hormone called erythropoietin, often abbreviated as EPO. This hormone travels through the bloodstream to the bone marrow and gently asks it to produce more red blood cells. It is not a command. It is a request. A chemical signal that says, softly, we need more carriers. There is not enough oxygen, and the bone marrow responds, increasing production, releasing more cells into the river, restoring the balance. This feedback loop operates continuously. If you travel to a higher altitude where the air is thinner, your kidneys notice the lower oxygen levels and release more erythropoietin. Within days, your bone marrow begins producing extra red blood cells. Your body adapts to the new environment without you having to do a thing. Perhaps there is something comforting in this, the idea that your body listens to itself, sends gentle messages, and responds with exactly what is needed. A quiet conversation happening inside you, all the time, and you can rest, knowing that the conversation will continue without you. Fact 24. Adapting to thin air. People who live at high altitudes in the Andes, the Himalayas, the Ethiopian highlands naturally develop higher levels of hemoglobin in their blood. Their bodies have adapted over generations to an environment where oxygen is scarce. At high altitude, the air pressure is lower, which means each breath contains fewer oxygen molecules. To compensate, the body produces more red blood cells and more hemoglobin, deepening its capacity to carry whatever oxygen is available. This adaptation can happen within weeks if you travel to a high-altitude location. But for populations that have lived at high altitude for thousands of years, the adaptation is built into their genetics, a permanent adjustment, written into the DNA and passed from parent to child. It is one of the most beautiful examples of the human body's ability to adjust to its environment, not through technology or tools, but through the quiet wisdom of biology. The blood changes, the river deepens, and life continues. Even where the air is thin, you might let your own breathing settle now, slow and easy. Your blood has all the oxygen it needs tonight. The air is thick and warm and gentle, and the river flows on. Fact 25. The only liquid tissue. Blood is classified as a connective tissue, the only connective tissue in the human body that is liquid. Unlike bone, cartilage, or tendons, which are solid and structural, blood is fluid and flowing, connecting every organ to every other organ through a continuous, circulating river. This classification surprises many people. We tend to think of tissues as solid things you can touch, things with structure and shape. But blood meets every definition of a tissue. It has cells, it has an extracellular matrix, the plasma, and it performs specific functions for the body. What makes it unique is that its matrix is liquid. It flows. It moves. It is not anchored to any one place, and because of this, it can reach every cell in your body, delivering what is needed and carrying away what is not. It is the river that connects everything, the tissue that touches every other tissue, the fluid that makes the whole body a single, integrated, living system. And so we have traveled through 25 gentle facts about the river within you, the cells, the plasma, the iron from stars, the garden inside your bones. You have met the river, and perhaps you have begun to feel it flowing. And so you have met the river, the cells, the plasma, the iron from stars. But a river is more than water. It carries things. It protects things. And in the next 25 facts, you will discover that this river inside you has its own guardians, quiet protectors who have been watching over you since the day you were born. Perhaps you might let your breathing soften a little as we continue. There is no rush. The river flows at its own pace, and so can you. If you are beginning to feel drowsy, that is a beautiful thing. You are welcome to close your eyes and let these words become part of your sleep. The river will still be there when you wake. Inside the river, there are guardians. They have been watching over you since before you took your first breath. Fact 26. 5 types of guardians. 5 types of white blood cells patrol your blood at all times. Neutrophils, lymphocytes, monocyte, eosinophils, and basophils. Each one has a different role in your defense, and together they form one of the most sophisticated protection systems in the natural world. Neutrophils are the most numerous, making up about 60 to 70% of all white blood cells. Lymphocytes handle long-term immunity and memory. Monocytes transform into larger cells that clean up debris. Eosinophils and basophils play specialized roles in specific types of immune responses. They are vastly outnumbered by red blood cells for every single white blood cell. There are roughly 700 red blood cells in your blood, and yet, these relatively rare cells are capable of mounting defenses that can protect your entire body. They do not sleep. They do not rest. They circulate through your blood and your tissues, scanning, patrolling, watching. They have been doing this since before you were born, and they will continue for as long as you are alive. Perhaps it is comforting to know that right now, as you rest, millions of quiet guardians are patrolling the river inside you. You are watched over, you are protected, and you do not need to do a thing. Fact 27. The first responders. Neutrophils are the most abundant white blood cells in your blood, and they are the first to arrive at any site of concern. Within minutes, they can detect chemical signals from damaged tissue and migrate to the location, squeezing through blood vessel walls to reach the area that needs attention. They are short-lived cells, most survive only a few hours to a few days. But what they lack in longevity, they make up for in speed and dedication. They arrive quickly. They act decisively. And when their work is done, they are quietly cleared away. Your bone marrow produces approximately 100 billion neutrophils every day, ensuring that there is always a fresh supply ready to respond. It is a constant cycle of creation and deployment. New cells born, sent into the river, and replaced before they are even missed. You might think of them as quiet first responders arriving before you even notice something has happened, doing their work, and then stepping aside for others to take over. They ask for nothing. They simply protect. maybe you can let your muscles relax a little more, knowing that even in stillness, your first responders are awake and ready. Fact 28. The Library of Immunity. Lymphocytes have a remarkable ability they can remember. Once they encounter a specific pathogen, they create memory cells that remain in your body for years, sometimes for your entire life. If that same pathogen ever appears again, your immune system can respond faster and more effectively. This is the principle behind vaccination, and it is also the reason why you rarely get the same illness twice. Your lymphocytes have built a library, a vast, detailed archive of every immune challenge your body has ever faced. Each memory cell is like a book on a shelf, waiting patiently for the day it might be needed again. There are two main types of lymphocytes, T cells and B cells. T cells coordinate the immune response and can directly address infected cells. B cells produce antibodies, specialized proteins that mark specific invaders for removal. Together, they form the adaptive immune system, a defense that learns and improves over time. Perhaps you can appreciate this, the idea that your body has been building a library for your entire life. One entry at a time. Each one a lesson learned and remembered. You carry this library with you now, in the quiet current of your blood. Fact 29. The gentle clearers. Monocytes are the largest of the white blood cells. They circulate in the blood for about 1 to 3 days before migrating into the tissues, where they transform into macrophages, a word that comes from the Greek for big eaters. Macrophages are the cleanup crew of the immune system. They engulf and digest cellular debris, dead cells, and anything the body identifies as not belonging. They work slowly and methodically, clearing the aftermath of immune responses and restoring the tissue to its normal state. But macrophages do more than clean. They also act as sentinels, presenting fragments of what they have consumed to other immune cells, essentially showing them what to look for. This communication is a vital link between the innate immune system, which responds to any threat, and the adaptive immune system, which targets specific ones. They are the gentle clearers of the river moving quietly through the tissues, restoring order, passing along information, and ensuring that everything is as it should be. If you would like, you might imagine your body right now as a calm landscape after a quiet rain, everything washed clean, everything in its place. That is the work of your macrophages, happening all the time, beneath your awareness. Fact 30. Silent guardians of the night. Natural killer cells, often abbreviated NK cells, are a type of lymphocyte that circulates in your blood, scanning for cells that have been infected by viruses or that have undergone abnormal changes. They do not need prior exposure to recognize a threat. They are part of your innate immune system, ready from birth. What makes natural killer cells especially relevant tonight is that research has shown they are more active during sleep. Studies have found that sleep deprivation can significantly reduce the activity of NK cells. While consistent, restful sleep supports their function. This means that, right now, as you lie here and begin to drift towards sleep, your natural killer cells are becoming more effective. They are patrolling with greater vigilance, scanning with sharper precision. Sleep is not just rest for your mind. It is a time when your immune system sharpens its defenses. Perhaps you can let this knowledge settle softly around you. You are not just resting. You are actively supporting the guardians who watch over you. Every minute of sleep is a gift to your immune system, and the guardians are grateful. They work best when you rest. Fact 31. Billions of tiny sentinels. Your blood contains approximately 150,000 to 400,000 platelets per microliter. In total, that adds up to roughly 1 to 2 trillion platelets circulating through your body at any given moment. Billions of tiny cell fragments, each one ready to respond at a moment's notice. Platelets are not complete cells. They are fragments, pieces of much larger cells that reside in the bone marrow. But despite their small size, they play an enormous role. When a blood vessel is damaged, platelets are among the first to arrive. They stick to the site of the damage, clump together, and begin forming a plug that stops the flow of blood. This process happens within seconds, before you are even aware that something has occurred. Platelets have already begun their work sealing, plugging, protecting. They are the smallest formed elements in your blood, but they are always ready, billions of them, circulating through the river, waiting patiently for the moment they might be needed. You might let this be a quiet reassurance. Even the smallest things inside you have a purpose. Even the tiniest fragments are ready to protect you. Fact 32. Born from giants. Platelets are born from some of the largest cells in the bone marrow megakaryocytes. The name means large nucleus cell, and these cells are truly enormous by cellular standards, with nuclei that contain far more DNA than a normal cell. A single megakaryocyte can produce between 1,000 and 3,000 platelets. It does this by extending long, ribbon-like projections into the blood vessels of the marrow. These projections fragment into platelets, which are then swept into the bloodstream, tiny pieces of a giant cell, each one carrying the chemical machinery needed to help seal wounds. It is a remarkable process. The largest cells in the marrow give rise to the smallest elements in the blood. Size is not what matters, it is purpose. Perhaps there is something peaceful in this image, the idea of a giant cell, quietly releasing thousands of tiny protectors into the river, each one drifting into the current to take up its post. And those tiny protectors are inside you right now, floating softly through your blood, ready and waiting. You can rest. They have it under control. Fact 33. The cascade of 12. When a blood vessel is damaged, the body activates a clotting cascade, a series of 12 sequential reactions, each one triggering the next, like a row of dominoes falling in perfect order. This cascade converts inactive proteins in the blood into active enzymes, ultimately producing a mesh of fibrin that seals the wound. The cascade is extraordinarily precise. Each factor must be activated in the correct sequence, at the correct concentration, at the correct time. If any step fails, the cascade stalls. If any step overreacts, unnecessary clots can form. The body walks a tightrope between too little clotting and too much, and it does so with remarkable grace. This system evolved over hundreds of millions of years. It is found in slightly different forms in nearly all vertebrates, from fish to humans. It is one of the oldest defense mechanisms in the animal kingdom. You might imagine it as a series of quiet locks on a canal, each one opening in turn, allowing the current to flow exactly where it needs to go. Precise, ordered, unhurried. Maybe you can feel something of that precision in your own body now, the sense that everything is in order. Everything is held. Everything is working exactly as it should. Fact 34. The delicate net. Fibrin is the protein that forms the final structure of a blood clot. It creates a mesh, a delicate net of protein strands that traps platelets and red blood cells, forming a stable barrier over the site of damage. Under a microscope, a fibrin mesh looks like a web-thin, interlocking strands that cross and overlap, creating a structure that is both flexible and strong. It is woven by the body itself, using materials already present in the blood, assembled on site in a matter of minutes. This net is temporary. Once the underlying tissue has healed, the body breaks down the fibrin mesh through a process called fibrinolysis, dissolving the clot, clearing the debris, and restoring normal blood flow. Nothing is permanent. Everything is part of a cycle. There is something quietly beautiful about this, a net woven from your own blood, holding things together while healing happens beneath it, and then dissolving when it is no longer needed. Your body knows when to build and when to let go. Perhaps you might notice that same principle in yourself tonight, the ability to hold on when needed, and to let go when it is time. Fact 35. 4 phases of restoration. Healing follows 4 phases: hemostasis, inflammation, proliferation, and remodeling. Your blood plays a central role in every one of them. Hemostasis is the first phase, the immediate response. Platelets arrive. The clotting cascade activates, and the fibrin net is woven. Bleeding stops. This happens within seconds to minutes. Inflammation follows blood flow to the area increases. White blood cells arrive, and the body begins cleaning up damaged tissue. This phase can last several days. Proliferation is the rebuilding phase. New tissue is generated. New blood vessels grow, and the wound begins to fill with fresh, healthy cells. This can take weeks. Remodeling is the final phase, where the new tissue is strengthened and refined. This process can continue for months or even years, long after the surface appears healed. All 4 phases are orchestrated by signals carried in the blood growth factors, cytokines, hormones, and nutrients, all delivered by the river to exactly where they are needed. Perhaps you can feel a sense of trust in this, the knowledge that your body knows how to heal, step by step, phase by phase, and that the river carries everything the process requires. Fact 36. Y-shaped precision. Antibodies are Y-shaped proteins produced by B cells. Each antibody is designed to recognize and bind to one specific molecule, called an antigen, with extraordinary precision. The tips of the Y are the recognition sites, shaped to fit a particular antigen, the way a key fits a lock. Your body can produce an almost infinite variety of antibodies, each one uniquely shaped to match a different antigen. This diversity is generated through a process of genetic recombination in B cells, shuffling and rearranging gene segments to create millions of different combinations. When an antibody binds to its target, it does not destroy it directly. Instead, it marks it, flagging it for destruction by other immune cells, or neutralizing it by blocking its ability to interact with your cells. It is a system of recognition and communication, not brute force. Trillions of these Y-shaped molecules float in your plasma right now, each one a precision instrument, each one waiting for the one antigen it was designed to recognize. Maybe you can let this be a quiet marvel, the idea that your blood carries a library of lock and key pairs, each one unique, each one ready, All of it happening in silence, beneath your skin. Fact 37. 30 silent partners. The complement system is a network of over 30 proteins that circulate in your blood in an inactive state, waiting to be activated. When triggered, they work together in a cascade similar to the clotting cascade to mark, attack, and clear pathogens. Some complement proteins coat the surface of invaders, making them easier for phagocytes to recognize and consume. Others punch tiny holes in the membranes of bacterial cells, causing them to leak and dissolve. Still others recruit immune cells to the area, amplifying the response. The complement system is part of your innate immunity. It does not need to learn or remember. It is always present, always ready, always circulating through the river. 30 proteins, working in concert, each one with a specific role, each one activating the next in a precise sequence. It is a chemical orchestra, playing a defense symphony that you will never hear. Perhaps you can feel the quiet hum of this protection now, the knowledge that even as you rest, 30 silent partners are circulating through your blood, ready to respond. Fact 38. The warmth of defense. When your immune system detects a challenge, pyrogens, fever-inducing molecules, are released into the blood. These signals travel to the brain's temperature-regulating center and raise the body's set point. The result is a fever, your body intentionally warming itself. This warmth is not a malfunction. It is a strategy. Higher temperatures can slow the growth of certain pathogens and enhance the efficiency of immune cells. Your body creates an environment that is hostile to invaders and supportive of defenders. Fever is one of the oldest immune responses in the animal kingdom. Even cold-blooded animals seek warmer environments when they are fighting infection, a behavior called behavioral fever. The connection between warmth and healing runs deep in the history of life. You might feel a gentle warmth in your body right now, not from fever, but from the simple act of resting. Your blood vessels have dilated slightly, allowing more blood to flow near the surface of your skin. It is the warmth of peace, not of defense. But know that if defense were ever needed, your body would warm itself with the same ancient wisdom that has been protecting living creatures for millions of years. Fact 39. Inflammation as attention. Inflammation often gets a negative reputation, but in its acute form, it is one of the body's most healing responses. When tissue is damaged or under threat, the blood vessels in the area dilate, allowing more blood to flow in. White blood cells migrate to the site. Fluid accumulates. The area may become warm, swollen, or tender. All of this is the body paying attention. It is sending more resources, more immune cells, more nutrients, more oxygen to the area that needs them most. Inflammation is not the problem. It is the body's answer to the problem. Acute inflammation is temporary. Once the challenge has been addressed and healing is underway, the inflammatory response resolves on its own. The blood vessels return to normal. The extra fluid is reabsorbed, and the tissue begins to heal. Perhaps you can think of inflammation not as damage, but as care, your body sending everything it has to the place that needs it most. It is attention, not alarm. It is the river rising to meet a need. And right now, as you rest, the river is calm. The attention is gentle. Everything is at peace. Fact 40. 8 days of readiness. Each platelet lives only about 8 to 10 days. In that brief span, it circulates through the river, ready at every moment to respond if needed. If it is not called upon, it is quietly removed from circulation by the spleen and replaced by a fresh platelet from the marrow. 8 to 10 days of readiness. Not 8 to 10 days of action. Most platelets will never encounter a wound. They simply patrol, float, and wait, and then they are replaced. This constant turnover means that your body is producing billions of new platelets every day, ensuring that the supply is always fresh, always functional, always ready. It is a commitment to preparedness that never lapses. There is something quietly devoted about this billions of tiny fragments, living short lives dedicated entirely to being available, just in case. They do not know if they will ever be needed. They are simply ready. Perhaps you can feel a certain peace in that the knowledge that readiness does not require action. Sometimes it is enough just to be present, just to be available, just to be here, resting like you are now. Fact 41. The castle gate of the brain. Specialized cells lining the capillaries of the brain create a structure called the blood-brain barrier. Unlike the capillaries in the rest of the body, where substances can pass relatively freely between the blood and the tissues, the brain's capillaries are sealed tightly, allowing only specific molecules through. Oxygen, glucose, and certain amino acids can pass. Most large molecules, pathogens, and toxins cannot. The barrier is maintained by tight junctions between endothelial cells, supported by astrocytes, star-shaped brain cells that wrap around the capillaries and help regulate what gets through. This barrier protects the brain, the most sensitive and complex organ in your body, from fluctuations in blood chemistry. It creates a stable, controlled environment in which neurons can function without interference. You might think of it as a castle gate opening only for the right visitors, keeping out everything that might disturb the peace within. Right now, your blood-brain barrier is quietly doing its work, ensuring that the river delivers what your brain needs and nothing more. Your brain is protected. Your thoughts can settle. Your mind can rest. Fact 42. The keeper of balance. Albumin is the most abundant protein in your plasma, making up about 60% of all plasma proteins. Its primary role is maintaining oncotic pressure, the force that keeps the right amount of fluid inside your blood vessels. Without albumin, fluid would leak from your blood vessels into the surrounding tissues, causing swelling. Albumin acts like a gentle anchor, holding water molecules in the bloodstream through osmotic attraction. It also serves as a carrier protein, transporting hormones, fatty acids, and medications through the blood. Albumin is produced by the liver, and a healthy liver can produce about 12 grams of albumin per day. This steady production ensures that blood volume remains stable and that the river maintains its proper flow. It is one of those invisible workers, a protein you will likely never think about, but one that keeps the fundamental balance of your circulatory system intact. Without it, the river would overflow its banks. Perhaps you can appreciate the quiet balance of your own body right now, everything held in place, everything flowing where it should, everything in equilibrium. The keeper of balance is at work. Fact 43. The iron courier. Transferrin is a plasma protein whose sole job is to carry iron safely through the bloodstream. Iron is essential for hemoglobin production, but free iron in the blood can be toxic. It can generate harmful reactive molecules. So the body wraps iron in transferrin, keeping it safe and controlled during transport. Each transferrin molecule can carry 2 atoms of iron. It picks them up from the intestines, where iron is absorbed from food, or from the spleen, where iron is recycled from old red blood cells. It then delivers the iron to the bone marrow, where it is incorporated into new hemoglobin molecules. This is the iron cycle, a continuous loop of absorption, transport, use, recycling, and transport again. Almost no iron is lost from the body. The same atoms of iron may be used again and again, cycling through your blood for years. You might think of transferrin as a careful courier, carrying precious cargo through the river cargo that was once inside a dying star, then inside the earth, then inside your food, and now inside your blood. The same iron, making the same journey, over and over. Perhaps you can feel the quiet continuity of this cycle. Nothing is wasted. Everything is carried, delivered, recycled, and carried again. Fact 44. Learning self from other. One of the most remarkable things your immune system does is distinguish between your own cells and foreign ones. This process, called immunological tolerance, begins before you are born. During fetal development, immature immune cells are exposed to the body's own proteins. Cells that react strongly to these self-proteins are eliminated. Only those that can tolerate the body's own tissues are allowed to mature and enter the bloodstream. This negative selection ensures that your immune system does not attack you. This education continues throughout your life. Regulatory T cells actively suppress immune responses against self-tissues, maintaining tolerance even as your immune system learns to recognize new threats. It is a process of extraordinary subtlety, learning what belongs and what does not, what to protect and what to address. Your immune system has been learning this distinction since before you took your first breath. Perhaps there is something comforting in this, the idea that your body learned to recognize itself, to know what is you and what is not, and to protect what is yours. This recognition is happening right now, in the quiet of your blood, while you rest. Fact 45. Whispered instructions. Immune cells communicate with each other through small signaling proteins called cytokines. These molecules carry messages between cells, instructions to activate, to multiply, to migrate, to calm down. They are the language of the immune system. Cytokines work at very low concentrations. A tiny amount can trigger a significant response. They are released by one cell and received by another, often across short distances like whispered instructions passed between colleagues. Some cytokines promote inflammation, recruiting more immune cells to an area. Others are anti-inflammatory, signaling that the response has been sufficient and it is time to stand down. The balance between these signals determines the intensity and duration of the immune response. It is a conversation happening inside you right now, millions of cells whispering to each other, coordinating their actions, adjusting their responses. You cannot hear it. You cannot feel it. But it is there, in the quiet current of your blood. Perhaps you might let your own thoughts quiet down a little, knowing that the cells inside you are already communicating everything that needs to be said. You do not need to add to the conversation. You can simply rest. Fact 46. The quiet eaters. Phagocytes are immune cells that engulf and digest pathogens, dead cells, and debris. The word phagocyte comes from the Greek for eating cell, and that is exactly what they do. They consume what the body identifies as needing to be removed. Neutrophils and macrophage are both phagocytes. When they encounter something that does not belong, they extend their cell membrane around it, enclose it in a bubble called a phagosome, and then flood it with enzymes that break it down. The process is thorough and efficient. After digesting their target, phagocytes often display fragments of it on their surface, a process called antigen presentation. This allows other immune cells, particularly T cells, to examine the fragments and decide whether a broader immune response is needed. They are the quiet eaters of the river, consuming what is not needed, presenting what they have found, and keeping the current clean. They work without fanfare, without recognition, and without rest. Maybe you can feel the cleanliness of your own body right now, the sense that everything is being taken care of. Everything is being cleared. Everything is being maintained. The quiet eaters are at work. Fact 47. Endless renewal. Hematopoietic stem cells, the master cells of the bone marrow, have the ability to renew themselves indefinitely. Unlike most cells in the body, which can only divide a limited number of times before they wear out, stem cells can continue producing new copies of themselves for your entire life. This self-renewal is what makes the blood system sustainable. Without it, the supply of new blood cells would eventually be exhausted, and the river would dry up. But because stem cells can replenish themselves, the marrow can continue producing red blood cells, white blood cells, and platelets decade after decade. The process is carefully regulated. Too much stem cell activity can lead to problems. Too little can lead to insufficiency. The body maintains a delicate balance, ensuring that just enough new cells are produced to replace those that are lost. It is a system of endless renewal, a river that never runs dry because the source never stops flowing. Perhaps you can feel something of that renewal in yourself right now, even as you rest, even as you drift. Your body is renewing itself. New cells are being born. The river is being replenished, and you do not need to do a thing. Fact 48. The gift of plasma. Plasma can be donated and used to help others. It carries antibodies, clotting factors, and proteins that are used to treat people with immune deficiencies, bleeding disorders, burns, and other conditions. Plasma donation takes about an hour. The blood is drawn, the plasma is separated, and the remaining blood components are returned to the donor. The body replenishes its plasma within about 24 to 48 hours. This means that the healing power of blood can extend from one person to another. The antibodies in your plasma, the clotting factors, the proteins, all of these can be shared, carried from one body to another, continuing their work in someone else's river. There is something quietly generous about this, the idea that the river inside you carries things that could help someone else, that the same proteins protecting you right now could, if shared, protect another person in need. Perhaps you can let this thought rest softly. The river is generous. It carries more than you need. And sometimes, what flows through you can flow into someone else. Fact 49. The gentle flag. When antibodies bind to a pathogen, they do not always destroy it directly. Often, they simply mark it, a process called opsonization. The antibody coats the surface of the invader, creating a signal that phagocytes can recognize and respond to. Think of it as placing a gentle flag on something that needs attention. The flag says, quietly, this one can go, and the phagocytes respond, engulfing and removing the marked target with efficiency and care. Opsonization dramatically increases the speed and accuracy of phagocytosis. Without it, immune cells would have to rely on chance encounters. With it, they can identify and locate their targets with precision. It is a system of cooperation, antibodies doing the recognizing, phagocytes doing the removing, and the body being kept clean through their partnership. Perhaps you can appreciate this partnership now, the idea that inside you, different cells are working together, each doing its part, each supporting the others. No one cell does everything, but together, they do everything that is needed. Fact 50. Curtains gently closing. During the final stages of wound healing, specialized cells called myofibroblasts slowly contract, drawing the edges of the wound together, reducing the size of the area that needs to be repaired. This process is called wound contraction, and it is one of the most elegant aspects of healing. The myofibroblasts generate tension within the new tissue, pulling the margins inward, like curtains being gently closed at the end of a long day. Wound contraction can reduce the size of an open wound by up to 80%, significantly decreasing the amount of new tissue that needs to be generated. It is a way of letting the body do less work by using the tissue that is already there. Once contraction is complete and the wound is fully closed, the myofibroblasts undergo a process of programmed cell death apoptosis. Their work is done, and they quietly remove themselves, leaving behind a healed surface. Perhaps you can feel something of that gentle closing now, the sense of things settling, edges coming together, the day drawing to a close. Your body knows how to close what needs to be closed. And tonight, as you rest, perhaps you are closing something too: the busyness of the day, the noise of the world, the effort of being awake. The curtains are closing, and behind them, the river flows on. You are protected. You have always been protected. And now, if you are still awake, and it is perfectly fine if you are drifting, we are going to travel much further back through millions of years, back through different species and different oceans, back to the very beginning of blood itself. Because the river inside you is not new. It has been flowing, in one form or another, for over 500 million years. And the story of where it came from is one of the most peaceful stories you will ever hear. Perhaps you can feel your body settling a little deeper as we go. The guardians are watching. The river is calm, and the ancient story is about to begin. The river inside you is not new. It has been flowing, in one form or another, for over 500 million years. Fact 51. 500 million years of flow. The earliest forms of blood-like fluid appeared over 500 million years ago, in primitive marine organisms that drifted through ancient oceans. These early circulatory fluids were simple, mostly water with dissolved proteins and salts, but they served the same basic purpose that blood serves today, delivering nutrients and removing waste. Over hundreds of millions of years, this simple fluid evolved into something far more complex. Oxygen-carrying proteins appeared. Specialized cells developed. Immune defenses emerged. The circulatory system grew from an open bath of fluid surrounding the organs into a closed network of vessels and chambers. Every step of this evolution is still written in your blood. The proteins in your plasma, the structure of your hemoglobin, the design of your immune cells, all of these carry traces of a story that began 500 million years ago, in a world that looked nothing like ours. Perhaps you can feel the weight of that history now quiet and vast. The river inside you is ancient. It has been flowing since before there were trees, before there were lungs, before there were bones. And tonight, it flows through you. Let it carry you, gently, as it has carried so many others before. Fact 52. Blue blood. Not all blood is red. Some creatures use a completely different oxygen-carrying protein, hemocyanin, which contains copper instead of iron. When oxygenated, hemocyanin turns blue. Horseshoe crabs, octopuses, squid, and many species of spiders and crustaceans all have blue blood. Their hemocyanin is dissolved directly in the hemolymph, their version of blood, rather than being packed inside cells, as hemoglobin is in vertebrates. Hemocyanin is less efficient at carrying oxygen than hemoglobin, but it works well in cold, low oxygen environments. It is an ancient solution to the same problem: how to carry oxygen from one part of the body to another, arrived at through a completely different evolutionary path. The fact that life found two independent ways to solve this problem, one using iron, one using copper, speaks to how fundamental the need for oxygen transport is. The river must flow, and life will find a way to make it flow. If you would like, you might imagine a world where some rivers run red and others run blue, different colors, different metals, but the same quiet purpose: carrying life forward, one breath at a time. Fact 53. The blue blood that saves lives. Horseshoe crab blood has a remarkable property. It contains a substance called limulus amoebocyte lysate, or LAL, which clots in the presence of bacterial toxins. This makes it an extraordinarily sensitive test for contamination. For decades, horseshoe crab blood has been harvested and used to test medical equipment, vaccines, and injectable drugs for bacterial contamination. A single horseshoe crab's blood can be worth thousands of dollars, and the pharmaceutical industry depends on this ancient creature's immune system to ensure the safety of modern medicine. The horseshoe crab has existed in essentially its current form for over 450 million years, older than the dinosaurs, older than most trees, older than nearly every living thing on land. And yet, its blood chemistry is sophisticated enough to protect human patients in hospitals around the world. Perhaps there is something humbling in this, the idea that one of the oldest creatures on Earth carries blood that saves human lives. Ancient blue blood, protecting modern medicine, a gift from the deep past to the present. You might let this thought settle quietly. The river of life is generous, and it flows through more creatures than just us. Fact 54. Green and yellow rivers. Insects do not have blood in the way that we do. They have hemolymph, an open circulatory fluid that bathes their organs directly, rather than flowing through a closed network of vessels. Hemolymph is usually colorless, pale green or yellowish, and it does not carry oxygen. Insects breathe through tiny tubes called tracheae that deliver oxygen directly to their cells. Their hemolymph handles other jobs, transporting nutrients, hormones, and immune cells, and helping regulate temperature and hydraulic pressure for movement. The insect circulatory system is open, meaning the hemolymph is not confined to vessels. It sloshes freely through the body cavity, pushed along by a simple tubular heart. It is a radically different design from the closed circulatory system of vertebrates, but it works beautifully for creatures that are small and light. You might imagine a tiny world of green and yellow rivers flowing freely through the bodies of beetles and butterflies, carrying everything except oxygen, in a system so different from yours, and yet so perfectly suited to its purpose. Perhaps you can feel the diversity of life in this image, so many solutions to the same questions. So many rivers flowing in so many different colors. Fact 55. The fish with transparent blood. The Antarctic icefish is the only known vertebrate with no hemoglobin in its blood. Its blood is clear, transparent, and it survives by absorbing oxygen directly through its skin and gills from the frigid, oxygen-rich waters of the Southern Ocean. The icefish lost its hemoglobin genes through a mutation millions of years ago. In warmer waters, this would be fatal without hemoglobin. The blood can carry far less oxygen, but in the near-freezing Antarctic, oxygen dissolves readily in the cold water and in the fish's own plasma, making hemoglobin unnecessary. To compensate, the icefish has a larger heart than most fish of its size, pumping a greater volume of blood to deliver enough oxygen without the help of a carrier protein. Its blood vessels are also wider, reducing resistance and allowing the thin, clear blood to flow more easily. It is a creature that turned a genetic loss into an advantage, an evolutionary experiment in living without the protein that nearly every other vertebrate depends on. Maybe you can let this story drift softly through your mind. A fish with transparent blood, swimming through the coldest ocean on Earth, breathing through its skin, life finding a way, even without the tools that seem most essential. Fact 56. Ancient immune defense. Crocodile blood contains powerful antimicrobial peptides, small proteins that can destroy bacteria, fungi, and even some viruses on contact. Researchers have found that crocodile blood serum can kill bacteria that are resistant to conventional antibiotics, including some strains that pose serious challenges to modern medicine. Crocodilians have survived for over 200 million years, often in environments teeming with bacteria, murky swamps, stagnant water, decomposing organic matter. Their immune systems have evolved to handle levels of microbial exposure that would overwhelm most other animals. Scientists are studying these peptides in hopes of developing new antimicrobial treatments. The chemistry of an ancient reptile's blood may hold the key to addressing one of modern medicine's most pressing challenges. Perhaps you can appreciate the quiet irony that some of the most promising advances in medicine may come from creatures that have remained almost unchanged for hundreds of millions of years. The ancient river carries wisdom that we are only beginning to understand. And you carry your own ancient wisdom in the cells and proteins that flow through you tonight. Fact 57. Your first hemoglobin. Before you were born, you had a different type of hemoglobin. Fetal hemoglobin, called hemoglobin F, has a higher affinity for oxygen than adult hemoglobin. This means it binds oxygen more tightly, which allows it to pull oxygen from your mother's blood across the thin membranes of the placenta. This was essential for your survival before birth. You could not breathe air. You had no access to atmospheric oxygen. The only way to get oxygen was to take it from your mother's blood. And fetal hemoglobin was designed to do exactly that, to reach across the boundary between two bodies and gently pull what you needed. After birth, as you began breathing on your own. Your body gradually replaced fetal hemoglobin with adult hemoglobin, a transition that takes several months. By the time you were about 6 months old, nearly all of your hemoglobin was the adult form. Perhaps you can feel the tenderness in this, the idea that even before you were born, your body was reaching out, drawing oxygen from your mother, connected to her through a river that flowed between you. That connection is part of you still. It shaped the very first version of your blood. Fact 58. A memory of the ocean. The mineral composition of blood plasma is remarkably similar to seawater. Both contain sodium, chloride, potassium, calcium, and magnesium in roughly comparable proportions. This similarity has led some scientists to suggest that blood plasma retains a chemical memory of the ancient ocean where life began. The first living cells evolved in the sea, surrounded by salt water. When early organisms developed internal circulatory fluids, they likely used the seawater around them as a starting point, adjusting the concentrations over time, but retaining the basic mineral profile. Hundreds of millions of years later, your blood still carries this signature. The salt in your plasma, the minerals in your serum, they echo the composition of an ocean that existed before any creature had crawled onto land. You carry a memory of the sea inside you. Not a conscious memory, but a chemical one, written in the mineral balance of every drop of your blood. Perhaps you can feel something of that ancient ocean, now vast, warm, and peaceful. The sea is not far away. It is inside you, flowing through you, as it has been since the very beginning of life. Fact 59. Meteorite, iron. Iron found in meteorites is chemically identical to the iron in your hemoglobin. The same element, forged in the same stellar processes, scattered across the solar system by the same supernovae. When scientists analyze iron-nickel meteorites that fall to Earth, they find isotopic signatures that match the iron in terrestrial minerals and, by extension, the iron in your blood. There is no chemical difference. The iron in a meteorite and the iron in your veins share the same cosmic origin. This means that the iron you are using to carry oxygen right now, the iron in every hemoglobin molecule, in every red blood cell, was part of the same cloud of stellar debris that formed our solar system 4.5 billion years ago. Some of that iron became meteorites. Some became the Earth's core, and some became you. Maybe you can hold this thought gently as you drift. You share your iron with meteorites, with the Earth's core, with every star that ever scattered its elements into space. You are not separate from the universe. You are part of it, made from it, carrying it inside your veins. Fact 60. Draculin. Vampire bat saliva contains an anticoagulant protein called draculin named, yes, after Count Dracula. Draculin prevents blood from clotting at the bite site, allowing the bat to feed on a slow, steady flow of blood. What makes draculin medically interesting is its precision. Unlike many anticoagulants, which affect the entire clotting system, draculin targets a very specific step in the clotting cascade. Scientists have been studying it as a potential treatment for conditions involving abnormal blood clotting, where a highly targeted anticoagulant could be beneficial. The vampire bat itself is a small, gentle creature weighing about 40 grams, roughly the weight of a few coins. It feeds on sleeping animals, making a tiny incision and lapping a small amount of blood. The amount it takes is negligible. The host rarely even wakes up. Perhaps there is something quietly whimsical about this, a tiny bat with a protein named after a fictional count, carrying chemistry in its saliva that might one day help human medicine. The river of blood connects all creatures in ways both expected and surprising. Fact 61. The ancient leech. Medicinal leeches have been used in healing for thousands of years. Ancient Egyptian, Greek, and Chinese medical traditions all employed leeches, and their use continued in European medicine well into the 19th century. Leech saliva contains hirudin, a powerful anticoagulant that prevents blood from clotting. It also contains vasodilators, which widen blood vessels, and anesthetics, which numb the bite site so the host does not feel the leech attaching. Remarkably, medicinal leeches are still used in modern medicine, particularly in microsurgery and reconstructive surgery. When surgeons reattach severed fingers or transplant tissue flaps, leeches are sometimes applied to reduce venous congestion, their saliva helping to maintain blood flow in delicate tissues while the body's own vessels heal. An ancient creature, used for ancient healing, still relevant in the most advanced operating rooms in the world. The river of medical knowledge flows both forward and backward, drawing from the past as much as from the future. Perhaps you can let this be a quiet reminder that wisdom does not expire. Some of the oldest solutions are still among the best. Fact 62. The oldest blood type. Blood type O is considered by many researchers to be the oldest of the A-B-O blood types. Some evolutionary geneticists believe it appeared before modern humans migrated out of Africa, making it potentially the original blood type of our species. Type O blood lacks both the A and B antigens on its red blood cells, which is why O-negative blood can be given to patients of any blood type in emergencies. There are no surface antigens to trigger an immune reaction in the recipient. The A and B antigens are thought to have evolved later, through genetic mutations that added sugar molecules to the surface of red blood cells. These mutations may have provided selective advantages in certain environments, possibly offering resistance to specific pathogens. Your blood type, whatever it is, carries a record of human evolutionary history. It is a molecular artifact, a trace of mutations that occurred thousands of generations ago, preserved on the surface of every red blood cell in your body. You might let this thought drift softly. Your blood type is not just a medical classification. It is a chapter in the story of human migration, written in sugars and proteins on the surface of cells that are flowing through you right now. Fact 63. Blood born from oxygen. Before photosynthetic organisms filled Earth's atmosphere with oxygen, roughly 2.4 billion years ago, there was no need for hemoglobin. The earliest life forms lived in an anoxic world, a world without free oxygen, and their metabolic processes did not require it. As oxygen accumulated in the atmosphere during the Great Oxidation event, it created both an opportunity and a crisis. Oxygen was toxic to many existing organisms, but it also offered a far more efficient source of energy than the anaerobic processes that had sustained life until then. Organisms that evolved to use oxygen thrived, and as they grew more complex, they needed a way to transport oxygen from the environment to their internal cells. Hemoglobin, or its evolutionary precursors, emerged to fill this role. Blood as we know it, red, iron-based. Oxygen carrying is a response to a world that was transformed by the first photosynthetic organisms. Without them, there would be no oxygen. no hemoglobin, no red blood cells, no river. Perhaps you can feel the depth of that connection. Your blood exists because ancient microbes, billions of years ago, began releasing oxygen into the atmosphere. Everything that followed, including you, grew from that moment. Fact 64. Hemoglobin in plants. Some plants contain a molecule called hemoglobin, a hemoglobin-like protein found in the root nodules of legumes such as soybeans, maize, and clover. Hemoglobin helps regulate oxygen levels in the nodules, creating the low oxygen environment that nitrogen-fixing bacteria need to convert atmospheric nitrogen into a form plants can use. The discovery of hemoglobin in plants surprised many scientists. It was long assumed that hemoglobin was exclusively an animal protein, but the gene for hemoglobin appears to be ancient, present in the common ancestor of both plants and animals, dating back over 1 billion years. This means that the hemoglobin in your blood and the hemoglobin in a soybean root share a common evolutionary origin. They have diverged enormously in function. One carries oxygen through a circulatory system. The other regulates oxygen in a root, but they are distant relatives, descended from the same ancestral gene. Perhaps you can feel the breadth of this connection. Hemoglobin is not just yours. It belongs to the whole tree of life, plants and animals alike, all carrying variations of the same ancient molecule. Fact 65. The largest river. A blue whale's heart pumps approximately 220 liters of blood, with each beat roughly the volume of a large bathtub. The blue whale is the largest animal that has ever lived on Earth, and its circulatory system is scaled to match. A blue whale's heart is about the size of a small car. Its aorta is wide enough for a human child to crawl through. Its blood vessels form a network that reaches every part of a body that can be over 30 meters long and weigh more than 150 tons. And yet, the fundamental design is the same as yours, a muscular pump pushing blood through arteries, capillaries, and veins. The same hemoglobin, the same iron, the same oxygen exchange, scaled up to almost unimaginable proportions, but built on the same blueprint. If you would like, you might imagine the river inside a blue whale, a torrent of warm blood flowing through a body the size of a building, powered by a heart that beats just 6 to 10 times per minute. Slow, massive, and deeply peaceful. Perhaps you can feel your own river now smaller, quieter, but just as complete. The same design, the same purpose, the same ancient plan. Fact 66. The tallest challenge. Giraffes have the highest blood pressure of any land animal, approximately 250 over 180 millimeters of mercury. This extraordinary pressure is necessary to push blood up their necks, which can be over 2 meters long, against the force of gravity to reach the brain. To manage this pressure, giraffes have evolved several remarkable adaptations. Their heart is exceptionally muscular, with walls up to 7.5 centimeters thick. Their blood vessels are reinforced with elastic fibers to handle the high pressure. And they have a network of small blood vessels at the base of the brain, called the rete mirabile, that acts as a pressure regulator, preventing dangerous surges when the giraffe lowers its head to drink. Every time a giraffe bends down and raises its head, its circulatory system performs a feat of engineering that would challenge any human designer, and it does so smoothly, effortlessly, dozens of times a day. Maybe you can appreciate the elegance of this, a body so tall that it required its own cardiovascular revolution. The river adapts. It finds a way. Fact 67. The slowest current. During hibernation, some animals reduce their heart rate to just a few beats per minute. The Arctic ground squirrel, for example, can lower its heart rate from over 300 beats per minute to as few as 1 or 2. Its body temperature drops to just below freezing. Its blood flow slows to a barely perceptible trickle. And yet, the animal survives. The blood still flows slowly, minimally, but enough to keep the cells alive. The brain receives just enough oxygen to maintain its basic functions. The tissues enter a state of suspended animation, waiting for the warmth of spring to return. Hibernation is one of the most extreme adaptations in the animal kingdom, a deliberate slowing of the river to almost nothing, sustained for weeks or months at a time. Perhaps you can feel something of that slowing in yourself right now. Your heart is beating more slowly than it was this morning. Your blood is flowing a little more gently. You are not hibernating, but you are moving in the same direction toward rest, toward stillness, toward the quiet end of the day. The river slows, and that is exactly as it should be. Fact 68. 3 hearts. Octopuses have 3 hearts. 2 branchial hearts pump blood through the gills, where it picks up oxygen from the water. The 3rd, systemic heart, pumps oxygenated blood to the rest of the body. Interestingly, the systemic heart stops beating when the octopus swims, which is one reason octopuses prefer to crawl rather than swim. Swimming is exhausting because it temporarily cuts off the systemic circulation. Octopus blood is blue, colored by hemocyanin rather than hemoglobin. It is less efficient at carrying oxygen than our red blood, but it works well in the cold, low oxygen environments that many octopus species inhabit. 3 hearts, blue blood, 8 arms, and one of the most intelligent brains in the invertebrate world. The octopus is a reminder that the river of life flows through an astonishing variety of designs, each one beautiful, each one perfectly suited to its world. Maybe you can let this image rest softly in your mind, a creature with 3 hearts, drifting through dark ocean water, its blue blood flowing quietly through a body that sees and solves and remembers. A different river, but a river all the same. Fact 69. Convergent protection. The blood-brain barrier, that selective gate that protects the brain from harmful substances in the blood, evolved independently in vertebrates and in some invertebrates. This is called convergent evolution, different lineages arriving at the same solution to the same problem, without sharing a common ancestor that had the trait. In vertebrates, the blood-brain barrier is formed by tight junctions between endothelial cells in brain capillaries. In some invertebrates, similar barriers are formed by different cell types using different molecular mechanisms. But the function is the same: protect the nervous system from fluctuations in blood chemistry. The fact that evolution invented this barrier more than once suggests that it is a deeply necessary adaptation that any organism complex enough to have a brain will eventually need a way to shield it from the unpredictable chemistry of the rebooted blood. Perhaps you can feel the depth of that necessity now, the sense that your brain is cradled, protected, sheltered from disturbance. This is not a luxury. It is something so fundamental that evolution arrived at it again and again, independently, across millions of years. Fact 70. Side by side, never mixing. In the placenta, maternal blood and fetal blood flow in close proximity, separated by membranes, only a few cells thick, but they never actually mix. Oxygen and nutrients pass from mother to child by diffusion, crossing these thin barriers without the two bloodstreams ever touching. This separation is essential. The mother and the fetus may have different blood types, different immune markers, different antibody profiles. If the blood mixed directly, the mother's immune system might recognize the fetal blood as foreign and mount a response against it. Instead, the placenta creates a space where exchange can happen without contact, a molecular marketplace where oxygen, glucose, amino acids, and antibodies are traded across whisper-thin membranes. It is one of the most elegant compromises in biology. Perhaps you can hold this image gently, two rivers flowing side by side, exchanging what they carry through the thinnest of walls, connected without touching. It is how you first received oxygen. It is how the river of life first flowed into you. Fact 71. Antifreeze in the deep. Some deep-sea fish and polar fish have evolved antifreeze proteins in their blood molecules that bind to tiny ice crystals and prevent them from growing, keeping the blood liquid in water temperatures that would freeze ordinary biological fluids. These antifreeze proteins are found in species that live in the coldest oceans on Earth, the waters around Antarctica and the deep Arctic. Without them, ice crystals would form in the blood, rupturing cells and destroying tissues. The proteins effectively lower the freezing point of the blood, allowing these fish to survive in temperatures as low as -2 degrees Celsius. Different fish species have evolved different types of antifreeze proteins independently, another example of convergent evolution solving the same problem through different molecular approaches. Imagine a river that refuses to freeze, even in the coldest place on Earth. That is what these fish carry inside them, a current that stays liquid when everything around it turns to ice. Perhaps you can feel the warmth of your own blood, now gentle, steady, flowing. You do not need antifreeze. You have a warm bed, a quiet room, and a river that flows at just the right temperature. Fact 72. A bittersweet compromise. The sickle cell trait, a genetic condition that alters the shape of hemoglobin, provides partial resistance to malaria. People who carry one copy of the sickle cell gene have red blood cells that are inhospitable to the malaria parasite, giving them a survival advantage in regions where malaria is endemic. This is one of the most well-known examples of balanced polymorphism, a genetic trade-off maintained by natural selection. In malaria-endemic regions, carrying one copy of the sickle cell gene is advantageous. Carrying two copies can cause sickle cell disease. The population maintains both versions of the gene because the heterozygous state 1 copy offers the best survival. It is a bittersweet compromise, shaped by millions of years of coexistence between humans and a parasite. The blood carries the record of this ancient struggle, written in the shape of hemoglobin, passed from generation to generation. Perhaps you can feel the weight of this history, the idea that your blood carries not just nutrients and oxygen, but the memory of evolutionary compromises made long before you were born. The river remembers. Fact 73. Invisible in the deep. Some deep-sea creatures have blood that does not absorb red light. In the deepest parts of the ocean, where sunlight cannot reach, red light is the first wavelength to be filtered out. Many deep-sea predators use red bioluminescent light as a kind of searchlight, invisible to most prey, because most deep-sea organisms cannot see red. But some creatures have taken this a step further. Their blood and body tissues are transparent to red light, making them virtually invisible even under red illumination. They have evolved to be unseen, not just in darkness, but in the specific type of light that predators use to find them. It is a remarkable adaptation blood that is invisible because it does not interact with the light around it. A river that flows in perfect camouflage. Maybe you can let this image carry you a little deeper into rest. A creature drifting through the darkest ocean. Its blood invisible, its body silent, moving through the water like a thought through a dream. Fact 74. Pink blood in the earth. Earthworms have hemoglobin, the same oxygen-carrying protein that colors your blood red, but unlike yours. Their hemoglobin is not contained inside cells. It is dissolved directly in their blood plasma, giving their blood a pinkish hue that is visible through their translucent skin. Earthworm blood is pumped by 5 paired aortic arches, often called hearts, that contract rhythmically to push the blood through a simple circulatory system. The blood flows through the worm's body, delivering oxygen and nutrients, and then returns to be pumped again. It is a humble system, no red blood cells, no complex immune defense, no elaborate clotting cascades, just hemoglobin in water, pushed through a simple tube, keeping a simple creature alive. And yet, the hemoglobin is the same molecule. The iron is the same iron. The oxygen it carries is the same oxygen. The fundamental chemistry of blood is shared between you and the earthworm beneath your garden. Perhaps you can feel the simplicity and the beauty of that connection. The river of life flows through all creatures, some grand, some humble, but all carrying the same ancient molecule in their veins. Fact 75. The discovery that changed everything. In 1901, the Austrian physician Karl Landsteiner discovered the ABO blood group system. Before this discovery, blood transfusions were unpredictable and often fatal. Sometimes the recipient's body would violently reject the donated blood, and no one understood why. Landsteiner showed that human blood could be classified into groups based on the presence or absence of specific antigens on red blood cells. He demonstrated that mixing incompatible blood types caused the red blood cells to clump together, a reaction called agglutination, which explained why some transfusions succeeded while others killed. This discovery made safe blood transfusion possible for the first time in history. It earned Landsteiner the Nobel Prize in Physiology or Medicine in 1930, and it transformed surgery, emergency medicine, and the treatment of blood disorders. One discovery, one observation about the surface of red blood cells, and millions of lives saved as a result. Perhaps you can let this be the last thought of this cluster, that the river of blood, flowing through every human being, was once a mystery so dangerous that sharing it could kill. And then one person looked closely enough to understand, and everything changed. 500 million years of blood, from ancient oceans to dying stars, from blue-blooded horseshoe crabs to transparent-blooded icefish, from the first circulatory fluid in a primitive marine organism to the complex, beautiful river flowing through you tonight. And now we come to the final movement, the most peaceful one. What happens to your blood when you sleep? What does the river do when the world goes quiet? If you are still listening, you are welcome here. And if you have already drifted away, that is beautiful too. The river does not mind. It flows either way. Perhaps you can feel your body settling into its deepest rest now. The ancient story has been told. The guardians are watching, and the river is about to slow down for the night. When you close your eyes and the world grows quiet, something beautiful happens inside you. The river begins to slow. Fact 76. Nocturnal dipping. During sleep, your blood pressure naturally decreases by 10 to 20%, a phenomenon that physicians call nocturnal dipping. This gentle decline is one of the most reliable signs of cardiovascular health, and it happens every single night without you having to think about it. When you lie down and close your eyes, your sympathetic nervous system, the one responsible for alertness and action, gradually steps back. The parasympathetic nervous system takes over, sending calming signals to your heart and blood vessels. Your arteries relax. Your heart beats more softly. The pressure inside your vessels eases, like a river widening as it enters a quiet valley. This nightly dip in blood pressure gives your heart and blood vessels a chance to rest. The walls of your arteries, which have been under pressure all day, can relax and repair. The endothelial cells that line your vessels use this time to restore themselves, clearing away damage and reinforcing their delicate structure. Perhaps you can feel this happening right now, a gentle easing, a quiet softening somewhere deep inside. Your blood pressure is already beginning to fall. The river is widening, the current is slowing, and your body is grateful for the rest. Fact 77. The slowing heart. Your heart rate drops by 10 to 30 beats per minute during deep sleep, sometimes even more. The heart that was beating 70 or 80 times per minute during the day settles into a rhythm of 50 or 60, sometimes fewer. This slowing is not a sign of weakness. It is a sign of efficiency. During sleep, your body's metabolic demands decrease. Your muscles are at rest. Your brain, though still active, requires less oxygen than during waking hours. The heart responds by easing its pace, conserving energy, and allowing itself a period of reduced workload. Each slower beat pumps blood with the same effectiveness, but with less effort. The heart muscle relaxes more fully between contractions. The coronary arteries, the vessels that supply blood to the heart itself, have more time to deliver oxygen and nutrients to the hardest working muscle in your body. Maybe you can feel your own heartbeat now, quiet and steady, softer than it was this afternoon. The river is finding its nighttime rhythm, and every slow beat is your heart saying, "I am here, I am resting, and I am still taking care of you." Fact 78. Vessels that heal themselves. During sleep, your blood vessels relax and undergo a process of self-repair. The endothelial cells that line the interior of every blood vessel, a surface area roughly the size of several tennis courts, use the reduced pressure and flow of nighttime to restore themselves. During waking hours, blood flow creates shear stress on vessel walls. Inflammation, oxidative stress, and the normal wear of circulation cause microscopic damage to endothelial cells. Most of this damage is repaired during sleep, when reduced blood pressure and increased nitric oxide allow the cells to focus on maintenance and regeneration. Your body also releases endothelial progenitor cells from the bone marrow during rest, fresh cells that travel through the blood to sites of damage and integrate into the vessel wall, replacing worn-out cells with new ones. Perhaps you can imagine your blood vessels as paths along the riverbank paths that are walked all day and then quietly repaired at night. Every crack filled, every rough edge smoothed. By morning, the paths will be ready for another day. But right now, they are being tended to, gently, in the dark. Fact 79. The quiet builder. Growth hormone is primarily released during deep sleep, particularly during the first few hours of the night. In large pulses that coincide with slow-wave sleep, this hormone travels through your blood to virtually every tissue in the body, stimulating repair, regeneration, and growth. In children, growth hormone does exactly what its name suggests. It promotes the lengthening of bones and the development of tissues. In adults, its role shifts toward maintenance and repair. It helps rebuild muscle fibers that were stressed during the day. It promotes the synthesis of new proteins. It supports the repair of connective tissue, skin, and organ cells. Without adequate sleep, growth hormone release is significantly diminished. The blood still flows, but it carries less of this rebuilding signal. The body's overnight construction project is delayed, scaled back, incomplete. You might let this thought settle quietly, right now, as you lie here. Growth hormone is beginning to flow through your blood, a quiet builder, traveling to every corner of your body, repairing what the day has worn down. You do not need to direct it. It knows where to go. Fact 80. The hormone of darkness. Melatonin levels in the blood rise dramatically at night, typically beginning 1 to 2 hours before your usual bedtime, peaking in the middle of the night, and gradually declining toward dawn. This hormone is produced by the pineal gland, a tiny structure deep in the brain, in response to darkness. Melatonin does not force you to sleep. Instead, it signals to your entire body that night has arrived. Every cell that has a melatonin receptor, and there are many, receives this message: it is dark. It is safe. It is time to shift into nighttime mode. Melatonin also has antioxidant properties. As it circulates through your blood, it helps neutralize free radicals and protect cells from oxidative damage. It supports immune function, influences body temperature, and helps synchronize the circadian rhythms of organs throughout the body. Perhaps you can feel the melatonin in your blood right now, a quiet chemical dusk, spreading through your body, telling every cell that the day is over. You are held by darkness, and darkness, tonight, is a friend. Fact 81. The midnight low. Cortisol, the hormone most associated with alertness and stress, follows a pronounced circadian rhythm in your blood. It reaches its lowest point around midnight, then begins a gradual rise through the early morning hours, peaking shortly after you wake up. This midnight low is significant. Cortisol suppresses immune function, increases blood sugar, and promotes alertness, all useful during the day, but counterproductive during sleep. By lowering cortisol at night, your body creates a window for deep immune activity, tissue repair, and metabolic restoration. The pre-dawn rise in cortisol, called the cortisol awakening response, is your body's way of gently preparing you for the day ahead. It begins while you are still asleep, gradually increasing alertness and energy, so that waking is a smooth transition rather than an abrupt shock. Right now, cortisol is at its quietest. The river carries very little of this activating hormone. Your body is in its most restful, most restorative state. There is nothing to be alert about, nothing to respond to, just rest, carried on a river of calm. Fact 82. Dreaming blood. During REM sleep, the stage most associated with vivid dreaming blood flow to the brain increases significantly. Some regions of the brain receive more blood during REM sleep than during waking hours. particularly the areas involved in emotion, memory consolidation, and visual processing. Your body is almost completely still during REM. Sleep, voluntary muscles are temporarily paralyzed to prevent you from acting out your dreams. But your brain is intensely active, and your blood responds by delivering extra oxygen and glucose to fuel this internal activity. The dreams you experience during REM sleep are supported by a surge of blood flow, a warm tide rising through the vessels of your brain, carrying everything your neurons need to weave stories, process emotions, and consolidate the memories of the day. Maybe you can let this thought carry you. When you dream tonight, the river inside you will rise to meet those dreams, flowing faster, flowing warmer, delivering oxygen to the visions your mind creates. Your blood does not sleep when you dream. It runs alongside your imagination. Fact 83. The night tide. During sleep, cerebrospinal fluid surges through the brain along the spaces surrounding blood vessels, a cleansing process called the glymphatic system. This system is most active during deep sleep, when brain cells shrink slightly, opening wider channels for the fluid to flow through. The glymphatic system clears metabolic waste products from the brain, including beta amyloid, a protein associated with neurodegenerative conditions. During waking hours, this waste accumulates. During sleep, it is washed away by a tide of cerebrospinal fluid that follows the pathways carved by blood vessels. Your blood vessels serve as both delivery routes and drainage channels, carrying oxygen and nutrients in, and guiding the cleansing fluid that carries waste out. It is a dual-purpose system, working hardest when you are least aware of it. Perhaps you can feel this cleansing happening now, a gentle tide washing through the quietest spaces in your brain, carrying away what is no longer needed, leaving everything a little cleaner, a little clearer. The river inside you does not just deliver, it also tidies up. Fact 84. Radiating warmth. In the hour or two before sleep, blood flow to the skin increases, particularly to the hands and feet. This vasodilation causes your body to radiate heat outward, which lowers your core body temperature. This drop in core temperature is one of the strongest signals to your brain that it is time to sleep. The warm hands and feet you might feel before falling asleep are not incidental. They are part of a carefully orchestrated thermoregulatory process. Your blood is deliberately redirected toward the surface of your body, releasing heat into the environment and cooling the internal organs. A lower core temperature supports deeper, more restorative sleep. It slows metabolic processes, reduces oxygen consumption, and creates the physiological conditions under which growth hormone and immune activity are most effective. If your hands or feet feel warm right now, that is your blood doing its work, radiating the warmth of the day outward, cooling the river inside, preparing you for the deepest rest. Perhaps you can feel that warmth as a gentle gift, your body's way of tucking you in. Fact 85. Sleep builds your defenses. Sleep deprivation measurably reduces the production of antibodies, the Y-shaped proteins your immune system uses to recognize and neutralize threats. Studies have shown that people who sleep fewer than 6 hours a night after receiving a vaccination produce significantly fewer antibodies than those who sleep 7 hours or more. Your immune system relies on sleep to build its defenses. During rest, immune cells are produced, trained, and deployed. The memory cells that record previous encounters with pathogens are consolidated. Much like memories in the brain, without sleep, This process is incomplete. The river of blood carries these antibodies and immune cells to every corner of your body, but it can only carry what has been made, and the making happens here in the quiet, in the dark, in the hours when you are not doing anything at all. Perhaps you can feel the purpose of your rest tonight. You are not just sleeping, you are building defenses. Your blood is being stocked with protectors, quietly, while you drift. Fact 86. T cells work better at night. Research has shown that T cells, key immune cells that identify and respond to infected cells, are more effective during sleep. Studies found that T cell integrin activation increases during nighttime rest, allowing these cells to bind more effectively to their targets. During the day, stress hormones like adrenaline and prostaglandins reduce integrin activation, making T cells slightly less adhesive. At night, when these hormones decline, T cells become stickier and more efficient at attaching to cells that need attention. This means that your immune system is sharpest while you sleep. The defenders in your blood are more capable, more attentive, more precise during the hours of darkness than during the busy hours of day. Maybe you can find comfort in this. While you rest, your T cells are at their best patrolling, recognizing, responding. You do not need to stay awake to be protected. In fact, the opposite is true. Your protection deepens when you let go. Fact 87. Steady sugar. Blood glucose levels naturally stabilize during sleep. In healthy individuals, blood sugar remains remarkably steady through the night, maintained by a careful balance of insulin sensitivity, liver glycogen release, and reduced metabolic demand. During deep sleep, your body becomes more sensitive to insulin, meaning less insulin is needed to manage blood sugar. The liver releases glucose slowly and steadily, providing just enough fuel for the brain and other essential organs without causing spikes or crashes. This overnight stability is significant. It ensures that your brain, which consumes about 20% of your total blood glucose, has a constant and reliable supply of energy throughout the night, enough to support dreaming, memory consolidation, and the quiet maintenance work of sleep. Perhaps you can feel the steadiness of this, your blood sugar holding even, your energy flowing quietly, your brain receiving exactly what it needs without excess or shortage. The river is measured, careful, precise. It knows how much to carry, and when. Fact 88. The rhythm of red. Red blood cell production follows circadian rhythms. Research has shown that the activity of hematopoietic stem cells in the bone marrow fluctuates with the time of day, with some studies suggesting that certain phases of blood cell production are enhanced during periods of rest. The bone marrow, that soft, spongy tissue inside your bones, is not a factory running at a constant speed. It responds to circadian signals, hormonal fluctuations, and the body's changing needs. During sleep, when growth hormone is elevated and stress hormones are low, the conditions for blood cell production may be particularly favorable. This means that some of the red blood cells flowing through you tomorrow morning may have been born tonight, created in the quiet darkness of your bones while you were sleeping. Maybe you can hold this thought gently. Your bones are making new blood right now. Not because you asked, not because you willed it, but because the river renews itself continuously. And the night is when the renewal is deepest. Fact 89. Cleaning while you dream. Fibrinolytic activity, the process by which your body breaks down blood clots, increases during sleep. Tissue plasminogen activator, or TPA, is released in greater quantities during rest, dissolving any small clots that may have formed during the day and keeping the blood flowing smoothly. This is your body's overnight cleaning crew for the circulatory system. During waking hours, the clotting system is slightly more active, ready to respond to any injury. During sleep, the balance shifts toward clot dissolution, ensuring that the vessels remain clear and open. It is a delicate balance, the body knowing when to build clots and when to dissolve them, shifting the emphasis based on whether you are awake or asleep, and it happens automatically, without any conscious input from you. Perhaps you can imagine the river being gently cleared as you dream, tiny obstructions dissolved, channels opened, the flow restored to its smoothest, most effortless state. By morning, the river will be running clean. Fact 90. Rest and digest. During sleep, the parasympathetic nervous system becomes dominant, the branch of the autonomic nervous system associated with rest, recovery, and digestion. This shift has profound effects on your blood and circulation. The heart rate slows, blood vessels dilate, blood pressure drops. Blood flow is redirected away from the skeletal muscles and toward the digestive organs, the liver, and the immune system. The body shifts from a state of readiness to a state of restoration. This is the rest and digest mode, the opposite of the fight or flight response. In this state, your body prioritizes healing, nutrient absorption, and cellular repair. The blood becomes a vehicle for restoration rather than action. You are in this state right now. Your parasympathetic nervous system is gently taking the lead, guiding your blood toward repair, guiding your body toward renewal. You do not need to fight. You do not need to flee. You only need to rest and let the river carry you. Fact 91. The relaxing molecule. Nitric oxide release increases during sleep, a small, simple molecule that has a profound effect on your blood vessels. Nitric oxide relaxes the smooth muscle in vessel walls, causing vasodilation, a widening of the blood vessels that reduces resistance and allows blood to flow more gently. During the day, blood vessels maintain a certain level of tone, a slight constriction that keeps blood pressure within the range needed for active life. At night, increased nitric oxide tips the balance toward relaxation, allowing the vessels to open wider and the blood to flow with less effort. This molecule is produced by the endothelial cells that line your vessels, the same cells that are repairing themselves during sleep. As they relax, they produce more nitric oxide, which relaxes the vessels further, creating a gentle cycle of increasing ease. Perhaps you can feel this relaxation spreading through you, a widening, a softening, a gentle opening of the channels through which your blood flows. The river is widening, the current is easing, and the molecule responsible is one of the simplest in all of biology. Fact 92. Ebbing and flowing with dreams. Blood pressure during sleep is not perfectly constant. It ebbs and flows with the stages of sleep. During deep non-REM sleep, blood pressure reaches its lowest point. During REM sleep, it rises slightly, sometimes fluctuating with the emotional content of dreams. This variation is normal and healthy. It reflects the dynamic nature of sleep, the brain cycling through stages of deep rest and vivid dreaming. the body responding with corresponding shifts in heart rate, blood pressure, and blood flow. During particularly intense dreams, blood pressure and heart rate may briefly spike your body, responding to the imagined events of the dream as though they were real. But these spikes are brief, and the body quickly returns to its baseline of quiet rest. Maybe you can let this image carry you the river inside you, rising and falling gently through the night, like a tide responding to the moon, sometimes deeper, sometimes shallower, but always flowing, always returning to calm. Fact 93, 95 to 100. Blood oxygen saturation typically remains between 95 and 100% during healthy sleep. Even though your breathing slows and your metabolic rate decreases, the efficiency of oxygen exchange in your lungs is more than sufficient to keep your blood fully saturated. This means that every red blood cell passing through your lungs picks up nearly as much oxygen as it can carry, even in the slowest, quietest moments of the night. The hemoglobin molecules in your red blood cells are almost fully loaded, each one a tiny cradle holding 4 oxygen molecules, ready to deliver them wherever they are needed. Your body does not struggle for oxygen during sleep. It receives it easily, naturally, effortlessly, the lungs and blood working in quiet harmony, maintaining the oxygen levels that your cells need without any conscious effort on your part. Perhaps you can feel the ease of this, your breath coming and going, your blood picking up oxygen with each exhale and inhale, delivering it without effort. The river is full. The supply is steady. There is nothing to worry about. Fact 94. One night of rest. A single night of good sleep measurably improves insulin sensitivity, meaning your cells respond more efficiently to insulin and manage blood sugar more effectively the following day. This improvement is detectable after just one night of adequate rest. Conversely, even one night of poor sleep can temporarily reduce insulin sensitivity, requiring the body to produce more insulin to manage the same amount of glucose. The blood carries more insulin, the cells respond less efficiently, and the delicate balance of blood sugar regulation is disrupted. This is one of the most immediate and measurable effects of sleep on blood chemistry. It demonstrates that sleep is not a passive state. It actively recalibrates the systems that regulate your blood, fine-tuning them for the day ahead. You might let this be a quiet encouragement. Tonight's rest is already doing something measurable. By morning, your blood will be more responsive, more efficient, more finely tuned, simply because you chose to sleep. Fact 95. Softer platelets. Platelet aggregation. The tendency of platelets to clump together follows a circadian pattern. During the nighttime hours, platelets are less sticky, less reactive, less prone to forming clots. They flow more gently through the blood, less likely to adhere to vessel walls or to each other. This nighttime reduction in platelet reactivity complements the increased fibrinolytic activity that also occurs during sleep. Together, these changes create a circulatory environment that is gentler, smoother, and less prone to clotting during the hours of rest. During the morning hours, platelet reactivity increases again, preparing the body for the physical activity and potential injuries of the waking day. But for now, in the quiet of the night, the platelets drift softly, unhurried, unactivated. Perhaps you can imagine them billions of tiny fragments, floating gently through the river, softer than they were this morning, carried along by a current that asks nothing of them tonight. Even the guardians rest. Fact 96. The new equilibrium. When you lie down, blood redistributes throughout your body. In the upright position, gravity pulls blood toward your legs and feet. When you recline, this gravitational gradient disappears, and blood flows more evenly, redistributing from the lower extremities toward the core, the chest, and the head. This redistribution is one of the reasons you might feel a slight fullness in your head or chest when you first lie down. It is your blood finding a new equilibrium, the river rearranging itself in the absence of the gravitational pull that shaped its flow all day. Your heart responds to this redistribution by slightly reducing its output. There is less need to pump hard. When gravity is no longer pulling blood away from the brain, the kidneys also respond, increasing urine production slightly as more blood flows through them. You might notice this shift right now, the sense that your body has settled, that the blood has found its resting pattern. The river is level now. No hills to climb, no gravity to fight, just a gentle, even flow from one end of your body to the other. Fact 97. Rest is anti-inflammatory. Inflammatory markers in the blood, including C-reactive protein, interleukin 6, and tumor necrosis factor alpha decrease with consistent, adequate sleep. Chronic sleep deprivation is associated with elevated levels of these markers, contributing to a state of low-grade systemic inflammation. Sleep itself is anti-inflammatory. The combination of reduced cortisol, increased growth hormone, enhanced immune regulation, and parasympathetic dominance creates an internal environment that actively reduces inflammation. The blood becomes less inflamed, the tissues less irritated, the body less reactive. This is one of the most significant things sleep does for your blood and your body. Inflammation is implicated in nearly every chronic condition, and the simplest, most accessible way to reduce it is to sleep well, consistently, night after night. Perhaps you can feel the quieting of inflammation right now, a subtle cooling, a gentle easing, as the anti-inflammatory chemistry of sleep spreads through your blood. Rest is not passive. Rest is medicine. Fact 98. The drowsiness molecule. Adenosine, a byproduct of cellular energy metabolism, accumulates in the brain during waking hours. The longer you are awake, the more adenosine builds up, binding to receptors that promote drowsiness and suppress arousal. This is your body's way of tracking how long you have been awake and gently insisting that you rest. During sleep, adenosine is cleared from the brain. By morning, levels are low again, and you wake feeling refreshed. The drowsiness you felt earlier tonight was the accumulated adenosine of an entire day, pressing softly against your awareness, asking you to close your eyes. Caffeine works by blocking adenosine receptors, not by removing adenosine, but by preventing you from feeling its effects. The adenosine is still there, still accumulating. When the caffeine wears off, the drowsiness returns, sometimes more intensely. But tonight, there is no caffeine to interfere. The adenosine has done its work, and you have listened. You are resting, and the drowsiness molecule is being gently cleared from your brain, carried away by the same river that brought it. Fact 99. The heart dancing softly. Heart rate variability, the slight variation in time between heartbeats, increases during deep sleep. This may seem counterintuitive, but higher heart rate variability is a sign of a healthy, well-regulated cardiovascular system. When heart rate variability is high, it means the heart is responsive, able to speed up and slow down fluidly in response to the body's needs. A heart that beats with metronomic regularity is actually less adaptable than one that varies slightly from beat to beat. During deep sleep, the parasympathetic nervous system enhances this variability. The heart is not rigidly holding to a fixed tempo. It is dancing softly, responding to the subtle rhythms of your breathing, your blood flow, and the quiet electrical signals of your nervous system. If you could hear your heart right now, you would not hear a metronome. You would hear something closer to music, a rhythm that breathes, that shifts, that dances gently in the dark. Your heart is not just beating, it is improvising. And that improvisation is a sign that everything is well. Fact 100. The quiet river. Right now, approximately 5 liters of blood are flowing through you. The same 5 liters that have been flowing since we began this journey through the red blood cells and the stardust iron, through the guardians and the healing cascade, through 500 million years of evolution. And now, through the quiet of your sleep, this blood carries oxygen from your last breath. It carries iron that was forged in a dying star. It carries antibodies, shaped by every challenge your immune system has ever faced. It carries growth hormone that is rebuilding your tissues right now. In this moment, as you lie still, the river never stops. Not when you sleep, not when you dream, not when you forget it is there. It flows through 100,000 kilometers of vessels, touching every cell, feeding every organ, clearing every waste product, repairing every microscopic injury. But tonight, it flows a little slower, a little gentler, a little more peacefully. This is the river at rest. Not stopped, never stopped, but resting. Just as you are resting, just as you deserve to rest. Perhaps you can feel it now. The warmth in your chest, the pulse in your fingertips, the quiet rhythm that has been with you since before your first memory. 5 liters, 100,000 kilometers, 25 trillion red blood cells, and all of it flowing gently, just for you. And so you have traveled the length of a river tonight, a river that began in dying stars and ends here, in the quiet warmth of your body. You have followed it through 25 trillion red blood cells, each one carrying iron that was forged in a supernova billions of years ago. You have met the guardians, the white blood cells and the platelets, the quiet sentinels that patrol the river and mend its banks. You have traced this river back through 500 million years of life on Earth, through blue blood and green hemolymph, through transparent ice fish and 3-hearted octopuses, through the ancient ocean that still whispers in the mineral balance of your plasma. And you have rested beside the river as it slowed for the night, as your blood pressure dipped, as your heart softened its rhythm, as your vessels widened and your blood flowed more gently than it has all day. You do not need to remember any of these facts. You do not need to hold on to any of this. Your blood already knows everything it needs to know. It has been doing this work for billions of years longer than there have been humans, longer than there have been lungs, longer than there have been bones. It will keep flowing through the night, carrying oxygen, clearing waste, rebuilding what needs rebuilding, defending what needs defending. All of it quiet, all of it gentle, all of it for you. You can let go now. You can release the last thought, the last image, the last word, The river does not need your attention to flow. It never has. So tonight, as the river inside you slows its current and your heart settles into its softest rhythm, may you feel the warmth of 100 trillion cells all working together, quietly, just for you. May you feel the stardust in your veins, the ancient ocean in your plasma, the 500 million years of evolution that shaped the blood flowing through you right now. May you feel the guardians at their posts, the white blood cells and the platelets, the antibodies and the complement proteins all watching over you while you dream. May you feel the growth hormone traveling to every tissue, the melatonin signaling every cell, the nitric oxide softening every vessel. And may you sleep deeply, peacefully, carried by the oldest river you will ever know, the one that has been flowing inside you since the very beginning. The river does not stop, but tonight, it whispers, "Good night."